In complex systems, changing a single variable rarely produces a predictable outcome. Instead, it ripples outward, multiplying until a minor adjustment generates total structural chaos. This exponential multiplication is the exact mechanism driving the most frustrating phase of the doctoral journey. Candidates dutifully incorporate committee feedback, only to trigger a seemingly infinite loop of contradictory revisions. The experience is near universal, and it usually sounds exactly like this. Whenever I incorporate my supervisor's feedback, I receive a new batch of comments. It feels never-ending. If you are a doctoral student, a PhD candidate, or an early career researcher, you have likely found yourself trapped in this exact loop. This endless cycle stems from a fundamental misunderstanding of the structural approach required during the revision phase. The primary error driving this paradox is treating committee feedback as an exercise in item-level compliance. Supervisors frequently leave localized notes in the margins of a draft. They identify a specific symptom, usually confined to a single paragraph or an isolated chapter section. The standard reaction is to execute a surgical fix for that exact symptom, rewriting just enough text to clear the comment from the document and satisfy the reviewer. But a dissertation is not a linear sequence of independent chapters. You cannot treat it as a collection of isolated parts to be repaired one by one. This graph represents what a doctoral study actually is, a highly sensitive, interconnected system. Approaching it as a disconnected checklist guarantees systemic failure. To understand why item-level compliance fails, we have to map the exact system dependencies of a rigorous study to define what we call methodological equilibrium. It begins here, with the research problem. This single node is the bedrock of the entire structure. The specific problem you select dictates all subsequent systemic requirements. Because the problem is defined, the purpose of the study and the specific research questions are locked variables. They are mathematically derived directly from the problem itself. Above them sits the theoretical framework. This establishes the specific analytical lens, firmly constraining how those questions can be explored. Finally, we add the operational execution nodes: methodology, sampling, data collection, and analysis. These must align tightly with the framework in the questions. These 8 architectural components do not operate independently. They are perpetually locked in bidirectional alignment, constantly informing and restricting one another. Methodological equilibrium exists only when all vectors between these specific nodes remain structurally sound. Now, introduce a localized perturbation to the system. Imagine a committee member mandates a small tweak to your research methodology. Under the flawed item-level compliance model, you rewrite your methodology section to satisfy the reviewer. On the surface, the methodology node is fixed, but instantly the connecting vectors to your sampling and analysis parameters are under severe strain. This isolated change alters the logic of the adjacent nodes. The new methodology no longer supports the sampling strategy you previously established, warping the overarching systemic alignment. Like placing an unequal load on a tense steel cable, the internal validity of the study snaps when the structure cannot support the shift. This localized fix is precisely what generates contradictory feedback in the next review cycle. Other committee members will read the subsequent chapters and rightfully flag the newly created misalignments. To prevent this collapse, we must audit downstream dependencies every time a core component is altered. Let's execute a practical case study, responding to a request to revise a research question. You cannot simply rewrite the sentence. First, you must evaluate the purpose node. Does the stated purpose of the study need to shift to accommodate the new phrasing? Next, follow the vector to methodology. Does the overarching research approach still logically fit the newly phrased question? Third, check the sampling node. Does your previously established participant criteria require recalibration to answer this specific inquiry? Fourth, evaluate data collection. Do the specific interview protocols or survey tools need to be adjusted to capture the right metrics? Finally, verify the analysis node. Confirm that your planned analytical methods remain mathematically valid for processing the data this new question will generate. The stark reality of the revision phase is that passively addressing one isolated comment actually requires proactively auditing up to 5 downstream dependencies. Maintaining methodological equilibrium requires a continuous, proactive evaluation of how localized changes impact systemic coherence. It requires a rigorous system dynamics check. This is entirely distinct from basic academic tasks like copy editing, proofreading, or formatting citations. Maintaining equilibrium means you must occasionally question or contextualize a supervisor's feedback, particularly if implementing it as written would sever the logical relationships in your broader system. When every revision is tested against the whole, the components rotate and align into a perfectly flush, unified structure. Adopting this systems engineering approach, rather than blind obedience to marginalia, is the only practical way to break out of the endless revision cycle. Contrast the two distinct doctoral revision workflows. On the left, item-level compliance yields checked boxes but a fractured system. On the right, methodological equilibrium maintains a cohesive dependency matrix. Success goes beyond clearing supervisor comments. Every revision must structurally strengthen the study's overall coherence. Passive compliance is dangerous. Uncritically accepting localized feedback without checking dependencies will gradually pull your study's components in conflicting directions. Remember, you are building a structure meant to withstand intense academic scrutiny. The internal logic must be impenetrable. Embrace your unique position. You are the sole architect responsible for the entire system. Individual committee members, by contrast, are often evaluating specific, isolated subsystems based on their distinct areas of expertise. Address their feedback rigorously, but view every requested change strictly through the lens of system dynamics. Address the feedback, but protect the equilibrium.